Alright, welcome to Rational Equations, Level 3. Now, in this very first example, it's going to look a lot like our Level 2 examples, however, it's just going to be slightly more complicated. So, how should we start this? Let's start by rewriting our function. We can do x over x minus 4. And notice, one thing that we want to do here is we want to take a look at the denominator of our second fraction, and we want to ask ourselves, can that thing be factored? Now, when you look at x squared minus 16, you should recognize that it is in fact a difference of squares. What does that mean? It means that we can write it into two factors, such that we know the start of each factor will be x, because x times x will of course give us this x squared. But our last term is negative 16, and there's no middle term. So we're essentially looking for two numbers that multiply to be negative 16, but add up to be 0. Pause the video, see if you can figure out these two numbers. Well, the numbers are actually going to be negative 4 and positive 4. We know that negative 4 plus 4 is equal to 0, and that negative 4 times 4 will be negative 16. And we set this equal to what's on the right, negative 8 over x squared minus 16. Now notice one thing, I didn't factor out this x squared minus 16 right here because I want you to understand that these things, even though they look different, they are the exact same. Well, what does that mean? It means that this factor right here, in order for us to combine these two fractions, we need to multiply it by its missing factor. So we see the x minus 4 and the x minus 4. So it turns out the factor that it's missing is in fact this x plus 4. Okay, so if we multiply the bottom by x plus 4, we have to multiply the top also by x plus 4. And notice, now that we've multiplied the bottom by x plus 4, this denominator, and this denominator are the same. So when it comes to solving the rest of this equation, we can essentially ignore it up until the very end. Okay, I see that my x here distributes, and we're going to get this. X squared and x times 4 will of course give us plus 4x. And notice I didn't have to change anything here, so I can just write that denominator plus 2x is equal to, and our numerator here is this negative 8. And so once we solve this equation, we'll have our values of x. Okay, so let's combine our like terms. I'm going to do two things. One, I'm going to combine my like terms, and two, I'm going to move this negative 8 over to the other side. The reason I'm doing that is because this is a quadratic function. We need to set it equal to 0. So what's the opposite of negative 8? Well, that would of course be positive 8. And so we'll add 8 right here as well. Let me go ahead and bring this right up here where I've got some room. And so we'll write x squared, and I see that 4x plus 2x will of course give me 6x. And notice we're also adding 8 plus 8 is equal to 0. Now from here, since it's a quadratic, all we're going to do is factor it. And remember, we know that x times x, of course, gives us x squared, so that's the easy part. And for this next part, I would encourage you to pause the video and see if you can figure out what two numbers multiply to be 8 and add up to be 6. And of course, that's going to be positive 2 and positive 4. Well, how do you solve a quadratic? You want to ask yourself, since this whole thing is set equal to 0, what value of x would make this factor equal to 0? So if I had to say x plus 2 equals 0, well, we're really asking, what is the opposite of positive 2? So I could say right here, our solutions to this will be this x is the opposite of positive 2, which is negative 2, and this x is the opposite of positive 4, which is negative 4. Now here's the very last thing we have to test out. So yes, these could be our solutions, but if we take either one of these and we plug it back into our denominators, our original of the original equation, if either one of these factors becomes 0, then we actually can't have that as a solution. Now notice this is a negative 4 and this is a positive 4. Essentially the only way that it can become 0 is if you have the opposite value. So this negative 2 is safe. However, we actually have to test out this negative 4 to see if it's actually a solution. So let's see. If I take this very first factor, x minus 4, and I'm testing out negative 4, instead of x, I'll write negative 4, and then this negative 4 right there, and I see that negative 4 minus 4 is actually equal to negative 8. And that's a-okay. As long as the factor doesn't equal 0, we're fine. However, what about this one right here? So I say, okay, x is negative 4, and then for that factor, it's x plus 4, so I write negative 4 plus 4. And notice, negative 4 plus 4 is, in fact, 0, so this right here is telling us, hey, negative 4 is not a solution. So it turns out the only actual solution to this equation is going to be x equals negative 2. I know there's a lot there. I would encourage you to pause the video and finish taking down these notes. Let's go on to our second example. Okay, here we are in our second example, and you'll notice it looks a little bit more complicated because we actually have a full standard form quadratic here. It's not a difference of squares. However, this is going to follow the exact same process as our last one. So let's go ahead and write this out. We can write 3x. This would be nicer. I have a little bit more space here. 3x over x plus 9. And then we'll write minus, and remember that negative there is actually going to be very important later on because that negative always has to be distributed. However, we'll deal with that in just a second. And once again, still dealing with some stylus issues, so really bear with me here. But on this bottom we have this x squared plus 12x plus 27, and we essentially want to say, hey, can we factor this thing? And so our questions become, well, what times what gives us x squared? And that's an easy one. We know that that will be x times x. However, what about this number 12 and this number 27? What two numbers multiply to be 27 and add up to be 12? And I would ask you to pause this video and see if you can figure this out on your own. Once again, what two numbers multiply to be 27 and add up to be 12? Well, those numbers are actually going to be a positive 9 and a positive 3. 9 plus 3 is 12, and 9 times 3 is 27. And of course, we can set this equal to this 2x plus 36. It's a weird 6, but I promise it is, over this x squared plus 12x plus 27. Okay, so we have this, and now notice the only factor that we're really missing here, because we have this x plus 9 in common, is that this needs an x plus 3. So we multiply the bottom by x plus 3, and what we do to the bottom we of course have to do to the top. Well, there we have an x plus 3 as well. Now notice at this point this denominator, and this denominator are all equivalent in value, so we can essentially ignore them moving forward. So we have 3x times x, which will of course give us 3x. Remember, x times x will give you x squared, plus here we have 3x times 3, which will be 9x. And then don't forget that this negative, whenever there's more than one term, it always has to distribute as well. And so negative times a positive will give us a negative 2x squared, and a negative times a positive again will give us a negative 2x. And here, of course, this is going to equal this other side of 2x plus 36. Looks like I'll have to do a little erasing here in a second just so we can have some space. Now from here, let's combine all of our like terms on the left. Let's simplify. So we have 3x squared minus 2x squared. Well, 3 minus 2 just gives us 1x squared, which will make this problem ultimately pretty easy. And then we have a 9x minus 2x. Let's see, 9 minus 2 would be 7x. And here, let's do another step as well. I'm just going to subtract this 2x here, because remember, whenever you have a quadratic, you want to set it equal to 0. And when I subtract it on the right, that means I'll actually have to wind up subtracting it on the left, so minus 2x. And in order to get rid of this positive 36, we can do minus 36. And what I do on the right, I also have to do on the left, minus 36. And of course, this will equal to 0. Now, we have to combine our like terms one more time. We have this 7x minus 2x, which now gives us x squared, doesn't change. And what is 7x minus 2x? Well, that would give us 5x. 5x here minus 36 is equal to 0. Now I'm going to have to do some erasing. What I would encourage you to do is I would encourage you to pause the video and finish taking these notes right now so that I can clear up some space. Alright. And I'm going to leave the left-hand side of this equation just so we have this denominator in its factored form. Because remember, we will need that denominator later on. But let me just kind of erase everything here on the right. And remember, if you missed it, you can always just kind of double-click on the left side of your screen, and it will take you back about 15 seconds. Pause it, finish taking your notes. Okay. Well, now that we have a little bit of space to work out with, switch back to this. Okay, so what we want to do is we want to take this equation right here and we want to factor it. So of course we know that x times x gives us x squared. That's the easy part. So we'll put my x right there, x, and x. Perfect. Now the question becomes, what two numbers multiply to be negative 36 and add up to be positive 5? And this one's a little bit trickier. I would encourage you to pause the video and play around with these numbers. What two numbers multiply to be negative 36 and add up to be positive 5? And what you'll actually find out is, since that middle term is positive, our larger number, which is going to be 9, has to be positive. And so we have positive 9 times negative 4. Let's see, why does that work? Well, 9 minus 4 gives us this positive 5. And 9 times negative 4 gives us that negative 36. So it turns out those were the two values we were looking for. Now here, all we have to do to find our solution is to say, hey, what value of x would make positive 9 equal to 0? And the opposite of positive 9 is negative 9, comma. Here, what value of x would make negative 4 equal to 0? And of course that would be positive 4. And so initially, it looks like our solutions might be negative 9 and positive 4. Now remember though, we have to go back to our original denominator, and we have to plug those in and see if those are going to equal 0. Now notice x plus 3, we have a negative 9 and a 4. We really don't care about that one right there. But let's take a look at x plus 9. And this assures us that the 4 is definitely a solution, but we have to test out negative 9. So let's see, I take x plus 9, I got a little space here so we can really write this out. We're saying our x value is negative 9, and so we want to do negative 9 plus 9, which is coming from that factor, because this is x plus 9, and negative 9 plus 9 actually gives us 0. Well, remember, we can never have 0 in our denominator. It makes a fraction undefined. So negative 9 can actually not be a solution. The only solution to this particular rational function is going to be positive 4. Alright. There we go. Alright, I hope that these two examples have helped you out, and good luck on this page.